Alright, let's look at the group of elements in the periodic table. Alright, a closer look at why periodic table isn't just, it's not just a list. Alright, so in this lesson, we should be able to explain how elements are organized in the periodic table. We should be able to interpret the basic element information from a periodic table, and we should be able to show the properties of different groups of elements. Alright, what's periodic table? A periodic table can also be called a chart that organizes all known chemical elements. So it arranges them by atomic number and group them based on shared properties such as reactivity, state of matter, and whether they are metals or non-metal. Alright, periodic table, like I said, is a chart that organizes all known chemical elements. Dmitry Mendeleev was the one who developed the basic periodic table before we have the modern periodic table. So scientists use periodic table to predict how elements react. We use it to engineer use it to choose metals for building and electronics. Doctor also use the periodic table they rely on it in making medicine, right? Let's look at the element square. Let's talk about it. Atomic number is shown here. The number shown around this area on the element square is called the atomic number. So it's usually at the top of the box. It tells you the number of proton in the nucleus of an atom. And down beneath the element, we have the atomic mass. This is the average mass of all the atoms of that element, including different isotopes. And we have the alphabet known as the chemical symbol. It can be one, it can be two letter abbreviation of elements name or Latin name. And we have the name of the element usually found under the chemical symbol. It is the full name of the element. So each element on the periodic table is placed inside a small box called element square. This square gives us key information about that element. Give us information about the atomic number. If you give us information about the atomic mass, give us information about the chemical symbol and the element name. Alright, now let's look at the period. The horizontal rows, like I said in the previous lesson, is the period. They are called period. There are 7 periods in total, number from top to bottom. Number from top, period 1, period 2, period 3, period 4, period 5, period 6, and period 7. Each period represents a new energy level, or we can say the electron shell being filled as you have moved from left to right. Now, when we look at each period, elements in this period have only one electron shell. Elements in this period have 2 has been filled, 3 has been filled, 3 electron shell, 4 electron shell, 5 electron shell, 6 electron shell, 7 electron shell respectively. So across a period, the atomic number increases by 1 from left to right. For example, sodium have atomic number of 11, while magnesium have atomic number of 12. So you can see the increasing order by 1. So this means each element has one more proton than the one before it. Calcium have one more proton before potassium. Scandium have one more proton before calcium. Titanium have one more proton before scandium. And vanadium have one more proton before titanium. Right? Electron shell. All elements in the same period have the same number of electron shell, but the number of electron in the outermost shell changes. The number in the outermost shell changes. Like period 1 element, hydrogen and helium have 1 electron shell. Period 2 element have 2 electron shell. This continue up to period 7. So as you move across a period, the properties of the element change gradually. So this gradual change is called a periodic trend, and it helps predict how elements will behave in a reaction. Alright, let's look at the group or family. The vertical column of the periodic table are called group or family. There are 18 groups of elements. Elements in the same group have the same number of valence electron. Remember, elements in the same period have the same number of electron shell, but elements in the same group have the same number of valence electron shell. That is, they have the same number of electron in their outermost shell. So valence electron are key in chemical bonding. Because of this, elements in the same group often behave similarly in chemical reaction. Thank you. So the next lesson we look at what each group entails and their properties. Thank you.